Hello, geometers. Today we are looking at segments that are inside or outside circles, segments that we deal with when we look at circles, and specifically their lengths. Now, I want to remind you that we just came out of talking about angles that happen when, for instance, sorry, that's a rough circle, two chords intersect, or the angles that occur when you have maybe two secants or tangent and a secant. We talked about angles with pictures that look very, very much like what we're looking at here, where it was like maybe this is 35 degrees and this is find x and this is 10 degrees, or we know this angle and this arc. All of those were angles and arc measures and that kind of thing. And we can remember that that's what we were looking at when we see degrees. That helps to remember that this is about angles. Here, the pictures look similar, but we're not talking about it. We're talking specifically about pieces of segments, parts of segments. And there's three different situations here, but we're basically going to break them down into two cases. Type 1 here is if you have two chords that intersect. And if you have two chords intersecting, they intersect inside the circle. Type 2 here is if you have two secant segments intersecting, and here you have a tangent segment and a secant segment. The tangent segment is the part with the A on it, and this part has points inside and outside the circle, so that makes it a secant segment. Both of these, either two secants or a tangent and a secant, meet outside the circle. So that's what I'm going to focus on, and that's what I do is, where do my secants meet? Again, this is very similar to how we talked about angles. So don't get confused about the fact that we are definitely talking about lengths now and not angles. These are pieces of segments and their lengths. Okay, sorry to do this, but you might notice it's a little less well focused. I had to change the resolution because I was getting glitchiness. So let's hope I'm getting less glitchiness. Okay, so when we have segments that meet inside the circle, which means they're both chords, here's how we're going to think about what happens. We're going to say that one part times the other part of one of the chords, meaning this whole thing's a chord. So like part A, the part labeled by A, times the part labeled by B. So the two parts of the same chord multiplied together equals, let me do equals in a different color here, getting all color coordinated. One part times the other part of the other chord. So this chord that has C and D, we're talking about part C times part D. So I'm multiplying the two parts of the same chord together, and I'm saying, oh, that gives me the thing as when I multiply the two parts of the other together. Here's an example right here. Okay, solve for x. This is all one chord, so the 10 and the x together. So 10 times x equals, and then I've got all of this is one chord, the 14 and the 15, so I'm going to multiply 14 times 15. 10x over here, and 210 over here. And then I divide both sides by 10, and I get x is 21. Okay, so part times part of one chord equals part times part of the other chord. Let's do another one like that right here. This time, notice it doesn't say solve for x, it says find BD. So find the whole length of BD. But since this part is represented by 5x minus 1, I'm going to have to know what x is in order to do that. So it doesn't matter which one I put on which side in terms of which chord. So I'm going to do AC on one side together. So on the left, 6 times 6, the two parts of AC multiplied together, equals 4 times all of this. You multiply something times something else that has two terms. You need to use parentheses. We need to make it look like this to understand that we're multiplying the 4 times that entirety that whole number represented by 5x minus 1, not just the 5x. So I'm going to distribute. So this is 36 equals 4 times 5x is 20x, and 4 times negative 1 is negative 4. Add 4 to both sides, and I get 40 equals 20, and x is going to equal 2. Now again, we weren't asked what x is, we were asked to find BD. So I need this whole length. So I need to go ahead and plug in 2 to the 5x minus 1. So 5 times 2 minus 1 is 10, minus 1 is 9. So this whole piece of chord BD is 9. So all of BD then, don't multiply. If we want this whole length, if we want a whole length that has pieces, we add the pieces together. 4 plus 9 is 13. BD is 13. So those are segments that meet inside the circle. In other words, they're both chords. Now, the other ones we're talking about up here, that they're calling type 2 and type 3, both of these we have segments meeting outside the circle. Okay? If you have segments meeting outside the circle, the way I like to think of it is part of the segment is sometimes outside, and then part is inside. So we could think of this as having an outer part. Okay? If it's a tangent, like right here, the outer part is really the whole thing. The entire segment is outside the circle. So here's the little rule we use for this. We do the outer part times the whole thing on one of the long pieces, on one of the segments. And then we go to the other one, say the outer part times the whole on the other one. Okay? So let's give some examples here. For this one, and I'm going to write it up here inside that box. The outer part of this one that says A and B is A. Now notice the whole thing, to get the entire thing, that would be putting together A and B. And we add them when we put them together. If you want a whole length and you're looking at pieces, you put the pieces together by addition. So this is A plus B. That's the whole thing. Equals, and then we go to the other segment, do the same thing. The outer part times the whole thing. So C times C plus D. Let me just give you a visual for that. I have a little more space here. So this is the outer part. And this is the whole thing. And over here, just this piece is the outer part. That's what I mean by outer part. And this is the whole thing. These aren't really math terminology as much as they are just ways we can think of it to make it a little bit simpler for ourselves. Okay, now what do we do then when we have a tangent? Well, we just said the outer part is the whole thing. For A up here, the outer part is the whole thing. So the outer part and the whole thing, when you're setting up your equation, you just multiply A times A. It's the outer part and it's the whole thing. So you have A times A, which will become A squared, equals, on the other one we have an outer part here, B times the whole thing. Again, for the whole thing, we very often have to add B plus C. The only time we wouldn't have to add to get the whole thing is if they have given it to us somehow. Like for instance, maybe they told me that this was 3, and then they drew something that told me, oh, that's the thing. It includes the 3, the part that's outside, and the part that's inside. So you would have to have an indication like that to know the thing. If it didn't have that, and it just said like 5 here, then to get the whole thing, I need to add 3 plus 5. Okay, so let's look at applying those, or really that one rule for those cases. Down here, we've got solve for x. Outer part is 9. Whole thing is 9 plus x, plus. Do not say 9x. We're putting them together by addition. Then on our segment, we've got the outer part is 8. the whole thing, you can write it out as plus, or you can add it to begin with, like add it separately. 8 is 27, but I'm going to go ahead and write it just so we know where that comes from. Now on the left here, this is distributive property. I have to distribute. On the right, I can put that together though. So 9 times 9 is 81 plus 9x equals, like I said, this is 27. So I have 8 times 27. And I get 216. The whole thing there is 27. We added it together. So 216. And then I can subtract 81 from both sides. Get 135. 9x equals 135. Divide both sides by 9. And we get x equals 15, I think. Yep, 15. Whenever you solve for x, always go back and look and see if that's what you were asked for or if you need to go plug it in somewhere. On this one, that's what I was asked for. Let's go ahead and look down at this one. It's the same rule because my segments meet outside the circle. Remember, when they meet outside the circle is when I'm going to use this whole outer part times the whole thing equals the outer part of the other one times the whole thing. You really can't get confused about when to use that one in terms of here or there because look, there's no outer part of anything over here. There would be no outer to describe. Okay, so here, let's look at this segment first. The outer part is 18. The whole thing is 18 plus x, not 18x, 18 plus x. And we will have to distribute there. On the other segment, the outer part is the whole thing. There's 24, so outer part times whole thing becomes just 24 times 24. So I'm going to distribute here. 18 times 18. Let's see what I get. 18 squared is 324. 18 times x is 18x. 24 squared on the other side is 576. Now I subtract 324 from both sides. Oops, did I mess up? Made some little extra sign there. There we go. 252. 18x equals 252. Divide both sides by 18 to get x alone. And I get 14. So x is 14. Now over here we have two more examples where the segments meet inside the circle. But the difference is on both of these, well, not on both of these, just on one, we were asked to go beyond finding x. So we have to find x first and then keep going. Here we're just finding x. All right, let's go up here first. Outer part is 10. Outer part times whole equals outer part times whole. Another way of looking at that, let's see if I can, I'll color coordinate it. Well, let me argue with myself for a second. Like here, I'll color coordinate over here. Outer part, and then here's the whole thing. And on the other one, 8 is the outer part. And then we got the whole thing. Okay. So here we have outer part is 10. Whole 10 plus 42. 10 plus 42 is 52. So I'm not showing my addition there. I just went ahead and did it. Equals, over here, the outer part is 13. Whole thing is 13 plus x. So 10 times 52 is 520. 13 times 13 is 169. And 13 times x is 13x. So I'm getting x alone. 520 minus 169 is 351. And you get x is 27. Now remember, we weren't done because that's not what we were asked for. We need the length of NL. NL is this entire segment, x plus 13. So that's 27 plus 13, which means NL is 40. Okay, last example here. Outer part, 27, times the whole thing, which is 27 plus 21. 27 plus 21 is 48. Equals, this is a tangent, the outer part is the whole thing. So when that happens, we multiply it times itself, which means squared. So we're going to have 27 times 48, still a little glitchy, sorry, 1296 equals x squared. Okay? If we have something squared and we need it unsquared, we want x, not x squared, we take the root. So I'm going to take the square root of this, square root of 1296, and see if it's going to be, oh, it is. It's a perfect square. So x is 36. And I am done there. Okay? Now, what I would like for you to do next, or what I suggest you do next, is freeze your screen on this picture here to remind you of what the rules are. Here's one rule for when they meet inside the circle, and it's a different rule if they meet outside the circle. And then turn your paper over and do the 6 problems on the back. If your paper is turned over, the rules are on the front, and so that's why I'm saying go ahead and freeze your screen like this. Assuming you're using a computer or laptop, I guess, well, yeah, you can do that. You can do it on your phone. And then give it a little while, and then I will go ahead and show you the answers and the work on the ones on the back. Okay, it just occurred to me that someone might be doing this and not have the next 6 problems. So let me go ahead and show those to you. It's number 1, 2. So now, even if you don't have the sheet, you can freeze your screen, try each of these 6 problems, and then come back and check. Okay, so pause now and try the next 6 problems. Spoiler alert, spoilers are coming as soon as you unpause. Assuming you've already tried them at this point, let's go ahead and look at how you should have set up 1 and 2. You should have noticed that these segments meet inside the circle on both of those. And so this is the rule you need to use for both of those. If you didn't set it up that way, go back and try again. For the next 4, notice that on all of these, the segments meet outside the circle. So you're going to use the other rule, which is the outer part times the whole thing on one of segment, for instance over here, equals the outer part times the whole thing on the other segment. If you didn't set it up that way, here's your chance to go ahead and pause and go back and set it up that way. Okay, here's the last thing I'll show you before I show you the answers, is how to set up each equation so that you can check and make sure you set it up correctly. That's half the battle. Okay, so here's the first 2, then there's 3 and 4, and finally 5 and 6. Okay? Time for the answers. Okay, here we go. I showed all my work for numbers 1 and 2, actually for all of them. If you didn't get the same thing as me, make sure you go through my work step by step and see if you can figure out where your work and my work are different, so that you can see what I did that you might have missed out on. There's 3 and 4. And finally, here's 5 and 6. Compare your work to mine carefully. I showed you every little bit of my work so that you can go through it and see what's different if you missed it. I hope you didn't miss many, maybe didn't miss any, and I hope this helped you a lot. Let me know what your questions are, and thanks for watching.